So welcome to this latest video on 162 Maths, and in this video we'll be going over the AQA AS Maths past paper of June 2019, paper 2, section 8, which is the pure section. Now as always, I'll also include a question breakdown in the description below so you can see which question refers to which topic. So let's get started on this paper 2 of June 2019. So looking at question 1, it says find the gradient of the curve y equals e to the power of minus 3x at the point where it crosses the y-axis, and we just need to circle our answer. Now for this, what we first need to do is, if we write down what y is, so we've got y equals e to the minus 3x, then if we work out the dy dx of this, so here we differentiate our power, which gives me minus 3. And then we've got our original function, which is e to the minus 3x. Now, where it crosses the y-axis, this is basically where x equals 0. So what I then want to do is substitute x equals 0. And if I type that into my calculator or work it out where this part here will just equal 1, we get the answer of minus 3. So our correct answer is our first option. It then says for question 2, find the centre of the circle x squared plus y squared plus 4x minus 6y equals 12. I want to tick the right box. So what we need to do is we need to factorise the equation. So here we've got, now if we factorise the pairs of x, so here we've got completing the square. So what we end up with is x plus 2 in our bracket squared minus the number inside the bracket squared, which is going to be 4. And then I can move on to the y. So I've got plus, and it's going to be y, then I halve the coefficient of y, which is minus 3 squared, minus the number inside the bracket squared, which is 9, and that equals 12. Now I don't need to worry about the radius because all I'm concentrating on is the centre. So looking at the numbers inside the bracket, we get minus 2 and we get positive 3. So the correct answer is going to be our second option. Then moving on to question 3, it says it is given that sine theta equals minus 0.1 and theta is between 180 and 270. Find the exact value of cos theta. Now this one is a little bit tricky in terms of its first glance, and the reason for that, because it's mentioning the exact value, it means I'm going to need to use one of the trig identities. So looking at this, what we're going to do is we know that sine squared theta plus cos squared theta equals 1. Now if if sine theta equals minus 0.1, then that means that sine squared theta is going to equal minus 0.1 squared, which equals 0.01. So if I substitute that in, so here if I substitute this into our equation, so what I end up with is 0.01 plus cos squared theta equals 1. So then that means that cos squared theta is going to equal 0.99, and then square rooting that, of 0.99, we get, and again we don't want to do inverse cos, so if I just type in the square root of 0.99 into my calculator, I get 3 root 11 over 10. Now in the question it also says that theta is between 180 and 270. So if I just quickly draw the cos graph, which looks something like this, that I know that when cos theta equals 3 root 11 over 10, then I'm going to be looking at the negative value, because from this we're looking at 90, then we're looking at 180, and then we're looking at 270. So we're looking for this region here. So therefore, if this value here is going to be 3 or root 99, then I then need to be looking at the negative value. So that needs to be plus or minus. So therefore, it's going to be minus 3 root 11 over 10. So then moving on to question 4, it says show that for when x is greater than 0, that log 10 of x over 4 over 100 plus log 10 of 9x minus log 10 of x cubed is identical to 2 lots of minus 1 plus 10 log 10 3x. Now for this, what you want to do is take one side. So I'm going to take the left hand side, and the left hand side looks like log 10 of x to the power of 4 over 100 plus log 10 of 9x minus log 10 of x cubed. Now with this, we notice that the bases are the same. So as the bases are the same, I can then use the rules of logs to write this as a single logarithm. So what this then becomes is log of x 4 over 100 times 9x all over x cubed. So then from this, what I can then do is probably simplify this. So I can write this as log 10 of, and it's going to be 9x to the power of 5 over 100 over x cubed, in which then I can write that, simplify that again by writing log 10 of 9x squared over 100, where the x is cancelling out. So if you're not sure about where that's come from, is if I just simplify all of this, we've got, not writing with the highlighter. So from this, I've got 9x to the 5 over 100 divided by x cubed, which then becomes 9x to the 5 over 100 multiplied by 1 over x cubed. That then becomes x squared, which then leaves me with what I've got in the bracket. Now, when you're thinking of logs, you always want to try and think, well, I can write this as a power. So this then becomes log 10 of 3x over 10 squared. Then from this, what I can then do is write this using again the rules of logs, that this then becomes log 10 of 3x, let's just take that 2 over, of minus log 10 of 10. And then from this, we notice that this part here is just going to equal 1. So we've got 2 lots of log 10 3x minus 1. And if we flip the two things in the brackets the other way round, we get 2 1 minus 1 plus log 10 of 3x, which equals the right hand side. Then moving on to question 5, it says that a triangular prism has a cross section ABC as shown in the diagram below. Angle ABC is equal to 25 degrees and angle ACB is equal to 30 degrees. BC is equal to 40 millimeters and the length of the prism is 300 millimeters. Calculate the volume of the prism, giving your answer to 3 significant figures. So with this, first thing we want to do is just make sure that all the units are the same. So we're looking at using our units of millimeters, and we don't need to change that because in the answer there is no indication about us needing to write it in centimeters or anything like that. Now if you prefer working with centimeters just to make the numbers easier to work with because they're going to be smaller, that's entirely up to you, but I'm going to stick to using millimeters. So the first thing I'm going to do is, first of all, to work out the volume, I need to work out the cross-sectional area. Now in order to work out the cross-sectional area, I need to use, so let me just write down the formula. So the cross-sectional area, I'm going to need to use half AB sine C. So looking at this, the angle that I need to know what this side here is going to be. So to work this angle out, which I'm just going to call, well, I can just work that out by knowing that angles inside a triangle add up to 180, that this angle here is going to be 125. Now, in order for me to use this formula for the cross, to work out the area of the triangle, I need to know what another side is going to be. So I'm going to work out what side this AC is going to be. So using the sine rule, what I get is I get that x, which is AC, over the opposite angle, which is sine 25, is going to be equal to the side that I know, which is 40 over sine 125. Then doing a bit of cross multiplying, I get that x is going to equal 40 sine 25 divided by sine 125, and that gives me an answer of 20.6368 blah blah blah. Then from this I can then work out the area of the triangle. So if I just do this here, so the area of the triangle is going to be equal to a half multiplied by 40 multiplied by the angle, the side x, which is what I've just found, which is 20.6368, and you might still have this on your calculator so you can use the exact value, and I need to multiply that by sine of angle C, which I've used, is 30. Then typing that all into my calculator, I get an area of 206.368, and that's going to be in millimeters squared. Now I've not finished because I then need to work out the volume. So therefore the volume of the prism is going to be the cross-sectional area, which is 206.368, which is still on my calculator, multiplied by the length, which is 300. And if I type that into my calculator, I get an answer of 61910.4, and that's in millimeter cubed. Now I need to round that number up to 3 significant figures, so it's going to be 61900 millimeter cubed. A little homage to Rey Mysterio there, and that's to 3 significant figures. Then moving on to question 6, it says that a curve has an equation of y equals 2 over x root x. It says the region enclosed between the curve on the x-axis and the lines of x equals 1 and x equals a has an area of 3 units. It says given that a is greater than 1, find the value of a, and it says fully justify your answer. So first things first, what I need to do is I need to rewrite this equation so that it's in index form. So how can I do that? Well, I can write that as y equals, and it's going to be 2 over, now if I take this x back into the third, then that's going to be the square root of x cubed, and then I can then write that using index notation, so that's going to be 2x to the minus 3 over 2. I can then integrate this, so then what I've then got is the integral of 2x to the minus 3 over 2 with the limits of a, which I know is greater than 1, and 1 dx, and it tells us in the question that this is equal to 3. So then from this, what I can then do is integrate this. So what I've then got is, again, increase the power by 1, divide by the new power, so that becomes 2x minus 3 over 2 plus 1 is minus a half, and divided by the new power, I get that, and I've got a1, and that equals 3. So then simplifying this further, what I then end up with, and let me just move this over here so we've got a bit more space. And so from this, what we've then got is, if I just neaten it all up, I get 4x minus 4x to the power of minus a half, and that's a to 1, and that equals 3. Then substituting the numbers in, what do I get? Well, substituting x equals a, I get minus 4a to the minus a half minus, and it's going to be minus 3 to the minus a half, and that equals 3. So then doing a bit of rearranging, I get minus 4a to the minus of a half equals minus 1, and so then a to the minus of a half equals a quarter, taking the 4 over. So then what does this equal? Well, this looks like 1 over root a equals a quarter. Then if I do a bit of cross multiplying, I get that root a equals 4, so therefore a equals 2. And there is my final answer. Well, actually, it doesn't equal 2 because I've gone the wrong way. It equals 16. Then moving on to question 7, it says that the points A, which has a coordinate of A3, and B, which has a coordinate of 10, 6, lie on a circle. AB is the diameter of the circle and passes through the point of 2, 4. The equation of the circle has equation of, and it's got the equation, it says where C, D, and E are all rational numbers. So, and the question is asking us to find the values of A, C, D, and E. Well, if I just do a little sketch of this circle, so I've got 2 points, which I'm just going to call A and B on either side. It doesn't really matter where they are, but we just know that they're in opposite sides. And we know that AB is the diameter of the circle, which I'm just going to call C. Now there is a point which I'm just going to call D, because obviously C has already been taken, so I'm just going to call that D. And D could be anywhere along that dotted line. Now, in order to work out what the centre is and the radius of the circle, is it tells me that by knowing this coordinate, that the gradient of BD is going to be the same as the gradient of AD. So looking at this, so the gradient of BD is going to equal the gradient of AB. So if I then work out the gradient of BD, so let me choose a thinner pen, so the gradient of BD, and again the formula I'm going to use for the gradient is y2 minus y1 over x2 minus x1, and I'm going to use this coordinate here and this coordinate here, so let me just write this as coordinate D. So then from this I've got 4, 2, and I've got 6, 10, and if I simplify that I get a quarter. So therefore the gradient of AB equals 1/4. So then using the gradient of AB and using these coordinates here, I get 6, 10, and I get 3A, and that equals 1/4. So simplifying that, what do I get? Well, I get 3 over 10 minus A equals 1/4. Then if I do a bit of cross multiplying, I get that 12 equals 10 minus A, so A equals minus 2. So then knowing that A equals minus 2, what I've then got, and let me just put a little line to show from this, so what we've then got is that A is minus 2, 3. We know that B is 10, 6, and we know that, and so from this we can then work out what C is. So C equals the midpoint of AB, and so if I add the two x ordinates, so the midpoint formula, let's use that a different colour, so the midpoint is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So using these coordinates, substituting it into that formula, we get that C is going to equal 4 and 4.5. So let me just put a little highlight of that. We can then work out what the radius of the circle is. So therefore the radius of the circle equals the distance of, let's go for BC. Now you could use A, it's entirely up to you, but I'm just going to go for this one just because we've got positive coordinates. So then from this, let me just get rid of that. So then using that D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So using that formula and this coordinate here and this coordinate here, we get that D equals, and we're going to get the square root of 4.5, well, actually it's going to be 4 minus 10 squared plus 4.5 minus 6 squared, And if I type that all into my calculator, I get d equals, and then that's going to be the square root of 38.25. Now going back to the actual letters, and again I've probably confused myself by using completely different letters here. So from this, what I've then got is that the centre, which looking at the coordinates is CD, equals 4 and 4.5. So therefore C equals 4 and D equals 4.5, and that the radius equals the square root of 38.25, which equals E squared. So therefore E equals 38.25, and there is my final answer. Now if you wanted to, you could write it as an equation, so I could write x minus 4 squared plus y minus 4.5 squared equals 38.25. So you could write it like that, but just going back to the question, it just says find the values of A, C, D and E, and so there are my values, and if I wanted to I can always play that A equals minus 2, and there we go. Now moving on to question 8, it says that a curve has the equation of y equals x cubed plus px squared plus qx minus 45. The curve passes through point R, which is at 2, 3, and the gradient of the curve at R is 8, and the question is asking us to find the value of P and the value of Q. So let's first of all take this first bit of information that we know, that the curve passes through R, which is 2, 3. So what we know is that when x equals 2, y equals 3. So substituting that in, what I get is 3 equals, and it's going to be 2 cubed plus p2 squared plus q2 minus 45. Now if I neaten all of that up, I'll get an equation of 2p plus q equals 20. And so I can just put a little box around that. Then if I then take this bit of information, so you'll know that the gradient of the curve at R is at 8. So basically what I know is that when x equals 2, then dy over dx is going to equal 8. So if y equals x cubed plus px squared plus qx minus 45, that dy over dx is going to equal 3x squared plus 2px plus q. Now when x equals 2, this is all going to equal 8. So if I substitute 2 into this, then what I end up with is I'm going to end up with 3 lots of 2 squared plus 2 times 2p plus q equals 8. And if I simplify all of that, I get 4p plus q equals minus 4. Let's put a little box around that. So then if I just put this as hashtag 1 and hashtag 2, I've then got 2 simultaneous equations. So if I just move down a little bit, then what we've got is we've got 2p plus q equals 20, and we've got 4p plus q equals minus 4. Now you can use your calculator, or you can then just go on and solve this, but you should end up with a p value of minus 12 and a q value of 44, and there is my answer. Then moving on to question 8b, it says calculate the area enclosed by the normal to the curve of R and the corner axes. So looking at this, well, first things first, let's start by writing down the equation that we've got, replacing our values of p and q that we discovered in part A. So here we've got x cubed minus 12x squared plus 44x minus 45. So first things first, what I need to do is I need to work out the gradient of the tangent. So let's first of all work out dy over dx. So dy over dx is going to equal 3x squared minus 24x plus 44. So then the gradient of the tangent is when dy over dx is going to equal at r, which is when x equals 2. So if I then substitute all of this into my calculator, I get the gradient of the tangent to be positive 8. So therefore, the gradient of the normal is going to equal the negative reciprocal, which is minus 1/8. Now then what I then want to do is work out the equation of the normal. And I know that m equals minus 1/8, and I know that it's the point r, which is at 2, 3. So then if I then substitute those numbers in, I can then work out what the equation of the normal is going to be. So the equation of the normal is going to equal y minus 3 equals 1/8 x minus 2. And if I simplify that further, I get y equals minus 1 over 8x plus 13 over 4. Now, in terms of what I then want to do, so I know I've got the equation of a normal, which has got a negative gradient, so it's going to look going like this. So this is the equation of the normal. Now, what I need to do is I need to find out where it crosses both of the axes. So this is the area that I want. So this is the area, or in other words, the answer that I want to find. And I know it's going to be a triangle, so I need to work out what this point here is, and I need to know what this point here is, so I can then work out the dimensions of that triangle. So using this line here, now this line is y equals minus 1/8 x plus 13 over 4. So where it crosses the x-axis, so the y-intercept, well, that's going to be just 13 over 4. So this value here is 13 over 4. So I can write this as a coordinate, so that's 0, 13 over 4, which is not really necessary. Now the x-intercept, now that's when y equals 0. So here I've got 0 equals minus 1/8 x plus 13 over 4. And if I do a bit of rearranging, I get that x equals, and it's going to give me a value of 26. So this value here is 26. So then what I've then got is I've got this triangle. I know the base is 26 and I know the height is 13 over 4. So then the area is going to be using base times height divided by 2. It's going to be equal to 13 over 4 multiplied by 26, all divided by 2. And that gives me an answer of 169 over 4, or 42.25, and that's in square units. Then moving on to question 9, it says that a curve has the equation of y equals f of x, where f of x equals x minus 2, and I've got x minus 3 squared. Find the exact coordinates of the turning point of C and determine the nature of each turning point and fully justify your answer. So first things first, let's have a look at what this graph actually looks like. Now if you've got a graphic calculator, then you will be able to plot this, and you might be able to then think, well, I can then use my calculator to find out what the answer is. But unfortunately, you can only use your calculator in this instance to check your answer, but not to actually use it as your answer. So I know that it's going to intercept the x-axis at 2 and at 3. Now, because I'm going to end up with a positive x squared, I know it's going to be like an S shape. So what this graph will look like is it will look something like that. Now, the turning points are this point here and this point here. So we know that we've got a turning point at 3, and so the coordinate then is going to be 3, 0. So this one is the one that the next one, or this one here, is the one that I need to find. So first things first, if I start by writing the equation out, so I've got f of x equals, and it's x minus 2, and then expanding this out, I get x squared minus 6x plus 9, which, simplifying f of x, is going to give me x cubed minus 8x squared plus 21x minus 18. Then if I differentiate this, so then what I've then got is f dash of x is going to equal 3x squared minus 16x plus 21. Now for at stationary points, f dash of x is going to equal 0. So what I've then got is 3x squared minus 16x plus 21 equals 0. Now again, you can either solve by factorising or by using the quadratic formula, in which you could just use your calculator. But basically what I'm going to get is two values of x where it equals 0 of 7 over 3 and 3. Now I know that 3 was always going to be one of the turning points. So I already know that here, these are the x-ordinates of my turning point. So therefore, there are a turning point at, and then it's 7, 3. Now if I then work out the y-ordinate, all I've got to do is, if I just, so to find y-ordinates sub x values into the original equation, and the original equation was x minus 2 x minus 3 squared equals y, in which then I get my y value of 4 over 27, which is not the nicest of coordinates, and I've got coordinate of 3, 0. So there's my turning points. So the next thing for me then to do is to work out the nature of those turning points. Now, looking at the diagram, again, I don't think that'll be valid for the 8 marks for me to use my diagram to tell me the nature of the turning points. So what I need to do then is to use the second derivative. So the nature of turning points. So here if I do the second derivative of x, so I'm differentiating this here, I get a function of 6x squared minus 16. So when f dash dash of x equals 7 over 3, then that is going to give me a value that is greater than 0, so less than 0 rather. So a maximum point. And when f dash dash of, when that equals 3, then it equals 0, so it's a point of inflection. So from this then, what we've then got is, actually no, it's going to be a minimum point, so I don't know why I've done that, so let's get rid of that. And there it's greater than 0, so a minimum point. So then what we've then got is 7, 3, 4, 27 is a maximum point, and 3, 0 is a minimum point. Yeah, apologies about the confusion there. Then moving on to question B, which I've seemed to have sidetracked. So here we're looking at graph transformation. It says state the coordinates of the turning points of the curve, and then here we've got this function here. Now as you can see, what we're doing is we are affecting both the x ordinates and the y ordinates. So by adding 1 to x, what we need to do is we subtract 1 from the x ordinate, and by taking away 4, we subtract 4 from the y ordinates. So here from our coordinates, if I just get that from part A again, so here I've got 7, 3 and 4, 27. So then here if I take away 1 and from this I take away 4, I end up with a new turning point of 4, 3 and minus 104 and 27 on the calculator. And if with my other turning point I've got 3, 0. And so if I take away 1 and take away 4 from those coordinates, then I end up with a new turning point of 2, minus 4. So then moving on to our last question of this section, it says, as part of an experiment, Zena puts a bucket of hot water outside on a day when the outside temperature is 0 degrees Celsius. She measures the temperature of the water after 10 minutes and after 20 minutes. Her results are shown below. Zena models the relationship between theta and the temperature of the water in degrees Celsius and time, which is t, by the model of theta equals a times 10 to the power of minus kt, where a and k are constants. By using t equals 0, explain how the value of a relates to the experiment. Well, a, when t equals 0, well then a, 10 minus 10 to the power of minus kt is just going to equal 1. So a is the initial value when t equals 0. Or you could say something along the lines of it's the starting temperature of the water. And then you could say at t equals 0. So something along those lines would be fine to give you the single mark. Then for B, then says show that log 10 theta equals log 10a minus kt. So for this, if we start by writing down the original model, which is theta equals a times, and it was 10 to the power of minus kt. Well, if we take the log of both sides, so we've got log 10 of theta equals log 10a, and then times means add, so it's going to be plus log 10 of 10 minus kt. Then I can then take that log 10 of 10, well, I can move the power to the front. Let's do that first. So I get log 10 theta equals log 10a minus kt log 10 of 10. And then this part here just equals 1. So therefore, what I've then got is log 10 of theta equals log 10 of a minus kt, which is what they wanted me to show. It then says using Zena's results, calculate the values of a and k. Now, I have absolutely no reason why they have put this question near the bottom of the paper, because obviously you're going to need a lot more space to actually do this, but let's have a go. So then using her results, well, when t equals 10 and theta equals 30, then we end up with a formula of log 10 of 30 equals log 10 of a minus 10k. And what I'm going to do is I'm just going to highlight this and just call that hashtag 1. Then if I move on to the second bit of information, so when t equals 20, theta equals it was 12, then what we end up with is log 10 of 12 equals log 10 of a minus, and it was 20k. And I could highlight that there, and I'm going to call this one hashtag 2. Then hopefully it's giving me no space, so let's just rewrite that together. So what we've then got is hashtag 1 was log 10 of 30 equals log 10a minus 10k, and I've got log 10 of 12 equals log 10 of a minus 20 log k, so that's hashtag 2. Now if I multiply this by 2, then what I end up with is 2 log 10 30 equals 2 log 10a minus 20k, and log 10 of 12 equals log 10 of a minus 10k. Then looking at simultaneous equations, which I'm hoping you can see where I'm coming with this, I can take away the 2. Actually, that should be a 20, not a 10. Let me just correct that. So then taking away, because we've got the same number of k's and the signs are the same, so I take away. So I've got log 10 of, so 2 log 10 30 minus log 10 of 12 equals log 10 of a. And then doing a bit of rearranging, writing this left hand side as a single logarithm, so I can write this as log 10, and it's going to be 30 squared, minus means divide, divided by 12 equals log 10 of a. And so a equals 30 squared divided by 12, which equals 75. Now from that, what I can then do is then work out k. So then using log 10 of 12 equals log 10 of 75 minus 20k. Doing a bit of rearranging, I get a k value of 0.0398, and that's to 3 significant figures. And so there are my values of k and a, which is what they asked me to find. It then says, Zena states that the temperature of the water will be less than 1 degree Celsius after 45 minutes. Determine whether the model supports this statement. Well, let's first of all write down the model using the numbers of a and k that we've found. So it's going to be 75 multiplied by 10 to the power of minus 0.0398 to the power of t. So then when t equals 45, then we get theta equals 75 multiplied by 10, and it's going to be minus 0.398 multiplied by 45. And if I type that into my calculator, I get a value of 1.21 and 356. Now, as you can see, in terms of comparing her statement, now we can then see that 1.21356 is greater than 1. So what we can then write is that the model does, let me write that properly, as that looks like CL. So the model does not support Zena's statement. So something along those lines would be absolutely fine. Then moving on to the last part, then it says explain why Zena's model is unlikely to accurately give the value of theta after 45 minutes. So you want to write something along the lines of that after 45 minutes the outside temperature may have changed. So something along those lines would be absolutely fine. And that concludes the end of section A.